Okay, we're reacting copper and sulfur to make copper sulfide. We're taking 80 grams of copper and reacting with 25 grams of sulfur. And part A would like for us to calculate the grams of product made. So grams of Cu2S, that's what we're solving for, that's our want. So they're giving us reactants, asking us to predict the amount of product. This is the stoichiometry. This is using the balance equations and your coefficients. I need to set up a BCA table. But before I can proceed with the BCA table, I know that BCA is for mole ratios. And so therefore, the only numbers that I can put into a BCA table are moles. There's a problem here. My given, they're not moles. I have grams of copper and grams of sulfur. So my first step will be to take those 80 grams of copper and convert them into moles of copper using its mass from the periodic table. 1 mole of copper has a mass of 63.55 grams. So grams cancel. You're left with moles. So 80 divided by 63.55. And you can keep 4 decimal places. 1.2589 moles of copper. This represents your before value for copper. We're going to repeat for sulfur. There are 25 grams of sulfur given to us in the problem. 1 mole of sulfur has a mass of 32.07 grams. Grams cancel, you're left with moles. So 25 divided by 32.07. Again, 4 decimal places, 0.7795 moles of sulfur is the before value. Now you're allowed to construct a BCA table. You have moles of each reactant. We can go ahead and construct BCA by writing the balanced equation first of all with the correct coefficients. And now the mole values that we just calculated are our before values for our reactants. So we have 1.2589 moles of copper and 0.7795 moles of sulfur. And we always start with 0 moles of product. Now for the change, you don't know which one the limiting reactant is by just looking at the numbers. So I want you to assign limiting to the first one, and we're going to test it. Subtract all 1.2589 moles from the copper. Since we're saying that the copper is a limiting, its value gets carried over to all the other columns, and those get multiplied by that mole ratio fraction. The mole ratio for sulfur, its coefficient is 1, and you're going to divide by the coefficient of the limiting reactant, and we just said that the limiting is going to be copper, and its coefficient is 2. And I real quickly calculate to see if I have enough sulfur. So 1.2589 divided by 2, I get an answer of 0.6295. And you pause and you evaluate. Do you have enough sulfur to complete the reaction? At the beginning, we have 0.7795 moles of sulfur. And the reaction says that we will use 0.6295. So yes, we have enough. So we will proceed using copper as our limiting reactant. Copper sulfide has a coefficient of 1. And again, the coefficient of limiting is 2. And that's going to be the same answer of 0.6295. And so now for the after row, the after is going to be equal to the before together with the change. 1.2589 minus 1.2589 will be 0 for your limiting reactant. For the sulfur, we started with 0.7795, and you will subtract 0.6295. So 0.7795 minus 0.6295, and you get 0.15 moles of sulfur. And for your product, it is 0 plus 0.6295, so obviously you're making 0.6295 moles of copper sulfide. So in part A, how many grams of product copper sulfide are produced? Look at your BCA table. Your BCA table tells you 0.6295 moles of copper 2 sulfide or copper 1 sulfide are produced. So I'm going to take the mole value, copper sulfide, and convert that into grams using the molar mass of copper sulfide. So copper sulfide has a molar mass of 159.17 grams. So 0.6295 times 159.17. And you get an answer of 100.1975. And again, we're going to round for sig figs. So go back to your given values in the problem. You have 80.00 grams of copper. That's 4 sig figs. And 25.00, that's also 4 sig figs. So that means your final answer should contain 4 sig figs. So 1, 0, 0, and then that 1, there's a 9 after it, so you're going to round up. So your final answer becomes 100.2 grams of copper sulfide. You have 4 sig figs in your answer because your givens had 4 sig figs. Part B, what is the limiting reactant? And part C, what is the excess reactant? B, your LR, is the one that's 0 after the reaction. So that is the copper. And C, the excess reactant, is what you have left over. That's your sulfur. Part D, how many grams of excess reactant are left over at the end of the reaction? So since we just said the sulfur is the excess reactant, go to my BCA table, locate the quantity that you have left over. You have 0.15 moles of sulfur left over after this reaction. And they want grams, so you're going to convert that into grams. 32.07 is the molar mass of sulfur. So 0.15 times 32.07. You get 4.8105. Again, 4 sig figs for our final answer because our givens had 4 sig figs. So 1, 2, 3, 4. There's a 5, so you're going to round up. So your final answer is 4.811 grams of sulfur. That contains 4 significant figures.